I want to give you the three rules, the electron configuration rules, that are used to fill sublevels and orbitals. The first rule is called the off-bow principle. A-U-F-B-A-U principle. And what it states is that electrons will fill the lowest orbitals first, lowest energy orbitals first. So it's kind of like filling up, a bucket full of golf balls. You have a bucket here, and you start throwing in golf balls, bloom, 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 and they go to the bottom first. Okay, lowest energy levels first, and then they start building up and up and up, more golf balls. All right. So, the first one is the off-bow principle. The next one is called the Pauli exclusion rule. And what it states is that you can put 2 electrons into each orbital. So, okay, 2 electrons per orbital. But they must have opposite spins. They must have opposite spins. Okay? So, I'll show you what I mean by that. Then the last one, the last rule, is Hund's rule. Oops. Didn't want to do that. Get rid of that. Okay? Is Hund's rule, and I talked about it last time. And Hund's rule states that you must fill empty orbitals within a sublevel in a given sublevel first. And I liken this to the city bus rule, where I used to live in Portland and I rode TriMet a lot, and there was an unspoken rule that you always sit at an empty seat on a bus before you go sit with a stranger. So here's an example of what's going to happen. I'm going to use, let's see, what am I going to use? I'm going to use the element, do I want to use phosphorus or nitrogen? Let's use something we haven't talked about. Let's use sulfur. How about sulfur? Okay. So here's sulfur, S. And sulfur has 16 protons, so therefore 16 electrons. So if I was going to write the electron configuration for sulfur, it would start out this. First principal energy level is 1. Okay. The sublevel is S. And there's 2 electrons in it, so I put the 2 in the superscript and it looks like that. So 1s2. After that's filled up, I then go to the second principal energy level, because in the first principal energy level there is no p sublevel. So I go 2. The first block I come to is the S. There's 2 electrons in that block. Then I move across the periodic table and I come to the 2p. There happens to be 6 electrons in that. So I'll put a 6 up there. Then I go drop down a level to the third principal energy level. First place I hit are the S's. 2 electrons there. and then move across and I hit the 3p sublevel, so it'll be 3p, and now I got to be careful because I'm almost to the limit of, I'm running out of spaces I need to go to get to sulfur. So I count across aluminum, silicon, phosphorus, sulfur, so there's going to be 4 electrons there. Now, like I said, in the other ones, I can always check myself, add up the electrons, 2, 4, 10, 12, 16. If 16 matches the atomic number, I did it right. So now I'm going to make an orbital diagram to illustrate those 3 rules that I talked about. For the highest principal energy level, which is going to be at the 3rd principal. So S's, since they have 1 orbital, get 1 box. P's, since they have 3 orbitals, get 3 boxes. Now I'm going to illustrate what happens. First off, this is a little bit about Hund's rule, Pauli exclusion rule, and the off-bow principle. But first off, with the off-bow principle, it says that electrons fill lowest energy levels first. So, okay, so that means in this diagram, you know that there's a bunch of boxes down here that I just don't want to do. So I don't want to draw these boxes. I'm going to start at the 3s. But the first electron to go into into any of these boxes would have to be at the lowest energy level. So there's going to be an electron in there, right? Now the Pauli exclusion rule says that whenever you put more than 1 electron into a orbital, it has to have the opposite spin to it. So that second electron now has to be oriented this way, like that, going down. And it doesn't matter which one you put up, whether one's going up or one's going down first, but you just have to be sure that when you put 2 electrons into each orbital that they have an opposite spin. Now I'm going to sit there and show you Hund's rule. And so in Hund's rule, I have 4 electrons that I have to account for. They're going to start off in the lowest orbital first, but they're going to fill empty orbitals before I double up. So I get 1 electron there, the next electron is going there, and as I fill these up, they all have to be spinning the same way. The 3rd electron is there, and now the 4th comes back and goes into there. So that's the filling order of how things should go. To give you an example of something that won't happen, okay, let's say I have a P sublevel with 3 boxes, and I have 1 electron there and 1 electron there. That will never happen, okay? If I'm putting 2 electrons into a sublevel and abiding by all the rules, Pauli exclusion, the off-bow, and Hund's rule, the first electron will go there, the second then will go there. Okay? So, that's it.